Now, we mentioned drawing pins in the introduction to this section. They can land pin up or pin down. So if this is our surface here, a drawing pin can land this way, pin up, or this way, which is pin down. So pin up or pin down. There's no symmetry that's going to enable you to theoretically work out that probability. So let's experiment. Let's get some drawing pins and do this type of thing with them. Now, a good way to do this is to give some students 10 pins each and get them to toss them maybe 50 times. And that means that they now have 500 pins that they've tossed. Now, let's suppose you've got 10 groups of students. You've then got 5,000 tosses of a drawing pin. That's quite a few. And you might get, say, 2,833 out of those landing pin up, and then you would say that your relative frequency is that. And perhaps over a number of years, you could collate the results of your students and you'd get a better estimate, provided you're giving everybody the same type of drawing pin. Drawing pins are different. Some of them, if you look at them, have much heavier parts here than others, which might have a thin part there. They have different construction, and different constructions of drawing pin are probably going to have different probabilities of landing pin up or pin down. So once again, this comes us back to whether we should pool our data or not. If everybody's using the same type of drawing pin, we should pool the data, especially if they're doing it under the same conditions. So not setting our experiment in different conditions every time, just people sitting at their desk, flicking some drawing pins out of their hand. Should be reasonable to pool if we have the same type of pin. But as soon as you move to a different type of pin, you should not pool those results, because the new type of drawing pin has, in all likelihood, a different probability of landing pin up.